All right, guys, thank you for joining the session with Reno and Vijal with the technologies topic. Um, I've decided to go this route because I think even for me today, I'll be sitting in this session. I think the easiest to learn is to actually do it and work with some of the technology that's available. And I think today, Reno will show you actually some easy technology that you can use that can assist you in when you're on construction sites to actually make it easier for you as well and a little bit more exciting as well. And that's the whole idea of that, to sort of develop those skills and actually understand that there's free software apps out there that you can use that's already available. All right, so it's hopefully you'll enjoy this session, and over to you, Rena. Thank you for your time. Appreciate it.
I will need some help to handle stuff.
Yep, no good. I'll help
to
you.
handle, not to break. All right, let's start with this presentation. My full name is Ruggero Lovreio, if you wonder. Everyone calls me Reno because it's too complicated and no one can make it. And I'm gonna show you a bit of existing technology that you can use to develop 3D models. And theoretically, you can start right after this class developing your 3D models, because you will see that you don't need any longer to have expensive toys to do it. Back in the day, it was nearly impossible. Things have been changed quite dramatically since 2018-19, and you'll see that now you need just to invent a new excuse to say, no, I can't do it. There is so much that you can do. So this is just an example to show you what you can develop for free, starting from a YouTube video. I'll show you what I did in few slides. So if you're wondering why my really strange name, I'm Italian, so that's why the name is so complicated. I am a civil engineer. At least I studied as a civil engineer back in the days. I never worked in the real world as a civil engineer because I got stuck in academia, study how people behave in disaster. And I've been doing this kind of research using all the emerging technology, virtual reality, augmented reality. Now we are using a lot of artificial intelligence, you name it, probably have used this technology. And of course, we have been using quite a lot of BIM in my research to develop a VR scene. And that was the reason they brought me a Messi to teach BIM. And this period I do just classes like this one because I'm fully involved in research. But I like to come to classroom to show the latest technology. And those presentations change every year because every year there is something new coming up. So it's not something that I created in 2018, period, done, reuse it. The beautiful things about our field is keep evolving. And I can tell you that since 2018, when I joined Massey University, the world was completely different from a digital technology point of view. We didn't have the possibility to do a lot of VR stuff. It was really painful to do it. And now it's getting much easier, much cheaper, and affordable even for students to have their own virtual reality headset. When I started doing VR in 2016, it was nearly impossible for anyone to get started by himself. This is what I try to do in my free time, but I don't have much of free time now. I build or fix telescopes, and those are pictures from my backyard in Auckland. They are not from Wikipedia. And it's a combination. It's another way to combine good stuff, like good technology, practical things, because there is a lot of hardware, software involved in it. And it's always a good thing to have the possibility to be challenged and learn. And it connects me back to my ancestor, Galileo. And I do a lot of YouTube. This is something that I've been starting doing from this year more intensely. I put a lot of tutorials and a lot of application how to convert digital data from one format to another format, interoperability issues, you name it. It's my bread and butter. I like to solve these kind of problems and provide solution to my colleagues. So today we are going to see different technology. The laser scanning technology has been there for years and is probably the most pricing one. I wouldn't expect you to have a laser scanner at home. They cost a lot. We will see soon. Photogrammetry and Gaussian splatting is a technology that is much more affordable, and you have already the technology in your pocket. Someone is already using here, not to listen what I'm talking about. It's your smartphone. I'm just teasing you. Before getting there, we need to see the difference between point clouds and meshes. So this is an example of a point cloud. Point cloud is a bunch of points. So if you open a point cloud data, it can be just 3D dimension. So you will see 3 numbers, X, Y, Z. Or point cloud can be also colored. So they have another 3 numbers, RGB. So if you open a point cloud file, it's just a simple text file with a lot of bunch of points that tells this point is to go in this absolute coordinate and give it this color. Not rocket science. If you have billions of them, generally you get up to 10, 20, 40 million, 50 million. You get something that almost looks like a 3D model, but it's not a 3D model. When we talk about 3D model, it's more when we talk about meshes. It's basically when you create and decompose a surface in a lot of triangles. And this is what we have in video games. All the video games that you play with are basically decomposed in 3D triangles, put them all together. And the magic comes when you do rendering with graphic cards. Now even smartphone can do this kind of advanced rendering. That's why you can do a lot of good shooting games on the smartphone. Or throw birds. I don't know if Angry Birds is still a thing. Back in the day was the main popular game, so you can tell that I'm old. And that's a mesh. So you can convert point clouds in meshes, and there are different ways to do it for free or using more advanced software that will give you high resolution meshes. So it really depends what is the end goal of your product. If you want to recreate a 3D model of a building for a virtual reality experience, you need to have a mesh. If you want to convert them in BIM, there are different solutions that might be capable to convert point clouds in a BIM document or meshes in a BIM. It really depends where you're trying to get to. And you will see that there is a possibility to convert generally point cloud to mesh, but it's possible to do the other way around. You have a mesh and you convert in point clouds. So back in the day, the most popular way to do 3D modeling of a building, 3D scanning of a building, was using 3D scanner. Henny, do you mind grabbing?
Yep.
Guess how much one of these toys cost?
$100,000.
Pretty close, 80,000. So it costs more than a car. Yes, yeah. So it costs more than a car. That's why if Henny drop it, he's gonna be in trouble.
I have to sell both cars.
Yeah. And probably a kidney.
Yep. That too as well. That
2?
should be the deposit.
Yeah, I think you need to have one. I think we still need one to run the business. So this is a 3D scanner. And it's a 3D scanner that uses laser. So basically what happens is that there is a laser machine down inside this machine. And what happens when we use laser scanner is basically every time you shoot a beam of laser, it bounces to the surface, goes back, and then to the sensor. So you can measure distance by just measuring the time that it takes to go to one point, back, and in the sensor. So if you know the speed of light, and we all know the speed of light, right? What's the speed of light? Everyone say it's c, because mc square from it's basically 300,000 kilometers per second. So you imagine the sensor that needs to be there, capable to detect the fraction of time that you need to have. And this happens so fast that this mirror here starts spinning, so it shoots in every kind of direction, capture back, and is capable to detect in half an hour. If I run a really high resolution scanning in half an hour, it will get 10 million points. The problem is that, and you can also get colors, because generally those scanners, let's remove this rubbish. Generally, this 3D scanner take also 360 pictures, so later you can link any pixel, any point in the space with the pixel of the picture and then give a color to every point. So it's quite expensive, unaffordable. So that's why we have other cheap solution, because there are a lot of limitations with this kind of device. You can imagine the occlusion. Of course, if I do 3D scanning from this point, I won't be able to see behind this table, so I need to locate it in multiple parts and then put all the 3D points all together, and it's called registration, that process. What if we need to go to the ceiling? Good luck. People were saying in the past, yeah, you can mount them on a drone. 80,000 New Zealand dollar on a drone doesn't feel like really comfortable to me. You can do it, but it's a lot of risk if you fall off and you destroy it. So let's go and see what has been used for, because you can do it for 3D modeling, for building, but this is one of the most exciting video that showed the utility to have sometimes 3D scanning.
Now this morning, the priest in charge of Paris's Notre Dame Cathedral says the landmark nearly destroyed by Monday's fire will be closed for 5 or 6 years. 21st century technology will likely be pivotal to its reconstruction. A New York professor made these 3D digital scans of Notre Dame accurate to a fraction of an inch. Jerika Duncan shows how this research, along with a video game, could be the foundation for the cathedral's restoration. Jerika, good morning.
Good morning. Really amazing.
So for the Notre Dame, 3D scanning was essential to rebuild as it used to be. Then it was combined also with 3D printing, because they managed to create a material that behaves like wood, but it's not wood, to reconstruct all the elements that were burned during the massive fire. And now Notre Dame is back to open to the public. When I went there, it was shut down because they were still rebuilding. But you can see that most of the time, if you have a digital replica of an old building and something happened, earthquake, fires, we have at least the knowledge if we decide to invest money to rebuild them. Let's go.
Rino, maybe just think about when you do your site, the closeout phase for the client, when you have to hand over all the manuals, all the build as plans, all of that. If you have a 3D model as well that you can provide the client, that's like a plan in itself. That they can keep, and if they need to upgrade or change or replace it, they go back to the 3D model.
Make sure you instruct them about what you give them. Sometimes I ask people, do you have the BIM of this building that just was built? No, they just give us PDF, this is the folder. Then you go inside, there is a Revit file. They don't even have an idea what they are handling. So,
Billion points of data.
let's go and see the alternative. The alternative is to use photogrammetry. Photogrammetry, it's a way in which you can rebuild a geometry, just use image. And this is how it works. It's a simple tutorial that shows the steps. The algorithm behind the scene is called structure from motion. And the first step is to take a lot of image that they overlap with each other. Either image, or you can shoot a video. And you can see here all these images are overlapping with the previous one, and it's the reason why. The reason why is because then you start detecting all the features from this image. And a feature can be a change of shape, a change of color, and you will see that this is a good thing, but also a limitation of this technology. And then if you do and you manage to extract this feature from all the image, then you can start pairing them and say this feature in this picture is the same in this other picture. And this is what the algorithm automatically does. And if you manage to get this matching well done, then you can use some advanced algebra to reconstruct the position of those points in a 3D space and reconstruct also the location of the camera in the same 3D space. So if you do it these thousands of times, then you have a point clouds just extracted using simple image, nothing more than what you have already in your pocket. Now the question for you is it more convenient to use photo or video? Which one has the highest resolution if you use your smartphone? The photos have the highest resolution. In fact, if you see the 4K, it's nothing comparable with the higher resolution that you can shoot with your phone. With the pictures, it takes more time because then you need to take one by one. If you use a video and you set the video 60 frames per second, you get smaller resolution but speed with higher speed. So it's really depending on what you're trying to do. And sometimes the answer depends on the results that you want to get. Sometimes you can use fewer picture but higher resolution, creates not blur, or videos, but make sure that the quality of the frames are good, because if you have a lot of frames that are blur, you basically feed the algorithm with rubbish, the results is going to be rubbish. There is no abracadabra behind the scene. It's always about the quality of the data that you give. There are entire course, if you go to YouTube, that explain all the equation behind structure from motion. It's just algebra, advanced algebra. The good news is that you don't need to do the math. They do it for you. So it's nothing like, there is nothing AI generative. It's nothing magic. It's just algebra that build back all the points. The two most popular software to do this stuff are Reality Capture that run on your own PC. Back in the day, they didn't give people a free license. The good news now is that you have a free license if you don't make money out of it. And the limitation is that it's gonna run on your PC. So if you try to run it for hours on a laptop, you're most likely gonna destroy your laptop because they use the full capacity of either of the CPU or GPU, depending on which stage of the process. So unless you have a really good ventilated computer, like the one that you see there, the fancy with all the blinking lights, that has a cooling system with liquid, you're gonna destroy your computer. Trust me, because I destroyed two of them. So I know how to smash. I'm the pro in pushing the boundary of computers. Polycam, it's another software that you can start using. And the good news is that you can download it on your smartphone or you can use it on web browser. And it's for free up to certain limits of video length and data that you can put in it. We have a license here that costs us $100 US per year. So if you have a company, $100 US per year is still affordable. And I'm gonna show you what you can get out of it. This is an example of a Polycam. Let's hope that the advertisement doesn't start. And I did it during COVID time. I put a video footage from YouTube because in COVID I couldn't go outside and do drone footage. And this is the 3D reconstruction out of this YouTube video. So all the white trail that you see here are all the pictures that were extracted from the video. So you can basically rebuild the trajectory of the drone and you can see the quality that you get. So you can even give it a try by getting existing drone footage that you find online and see how much you can get out of this. And you will discover soon that the quality really depends on the data that you have. If there are some points in which you don't have much of data, you won't get the magic out of it. So I want to, before we and see the limitation of this technology, I want to show you how Polycam looks like. So here I have several examples. I want just to show you a building that you're familiar with. So this was done using a simple 3D scanning, using a drone like the one that you see there.
Yeah. Just do the video.
So without any advanced stuff, you can do something like this. If you don't have the drone, you can still do the recording from where you can walk and still manage to get a reconstruction that start getting closer and closer to reality. The good news is that with this technology, you don't need to spend much money. You can start with a basic drone like this one, a DJI drone. And whenever you see that the grams of this drone is intentional, that they are not 250 grams. If you tick that box, then you need to start having a license to fly them. Because when you start getting something that is more heavy, then it can become easily a weapon if it falls on someone else. And we have one of them. So if you want to do more advanced stuff, then you need to purchase something like this. And for this, that's heavy, but it's without batteries. So those are the battery. And of course, they are super heavy.
And guys, when Marino is busy with this kind of stuff, also think about when you do your progress reports to the client. You can do 3D scan of the construction site. If you've got the technology, it's a quick one. You do it in the morning and you put it in your progress report. And when you present to the client or to the stakeholders, you can use a nice 3D model to show them, illustrate to them how far are you in the construction process. So it's just making it more exciting for people to look at this one.
It's very good for like overseas, if you're overseas.
Yes, that is as well.
I'm gonna show you in a few seconds how you can put then the project online, or you can put the project into a PowerPoint presentation. And that's what we did last summer with a lot of high school students. I was showing them how to create a 3D model and create a story using 3D models in PowerPoint. I'm gonna show you in a few slides. It seems that this model is too heavy to be loaded. Let's give it a few other seconds. So this is basically the 3D model of the facade of this building. And we did a drone fly for a few minutes. And you'll see that if you fly close enough to the roof, then you have also the shape of the tails. Let's go and see if we can open. Well, this is, try to get open up. This is the example of the Colosseum. I'm trying to open something relatively easy. Of course, you can do photogrammetry of pizza. Let's try to reopen this one that seems to be lighter. You have the possibility here to rescale, remesh, rotate, and also to have a blueprint of the building. So the limitation of structure from motion that is behind photogrammetry is that it doesn't know the scale. So it does all the geometry, but One unit for them can be 1 kilometer, 1 millimeter, 1 meter. So whenever you do photogrammetry, you need also to have something that you do a 3D models. So you have a reference point, you know, this is 1 meter. So later you resize using the specific information that you have already. So let's see if this is gonna get open. Yeah. This is a pretty big one. You'll see that if we get closer. You see where you start getting loss of resolution. And once again, it really depends on what's the resolution that you need. If you need a resolution of a millimeter, photogrammetry is probably not that yet. If you need a resolution millimeter, you need to use a 3D scanner. Like if you want to monitor if a dam is moving, and they move depending on the load of the water, don't use photogrammetry. If you want to understand how many cubic meters have been excavated, roughly you will get a good measurement using photogrammetry. So there is a solution and there are problems. You need to try to match which one is the cheaper and what will be the error that you will get depending on the solution that you try to get. Not bad, eh?
It's pretty good resolution.
And you'll see that when you don't get data, then you start getting artifacts. They are not great, but for the sake of this demonstration, it was good enough. And also in this case, you can go and see that we get a relatively good blueprint. So if we export it and we put it in Revit, then we can easily sketch this building.
We can make it as a layer in Revit and then just trace
Yeah.
it.
You put it as a base layer and then you draw on top of it. So the limitation of this technology is that it works with feature. So if you have an object that is really reflective, like something that is reflecting this screen, you will see that you will start getting problem because you start reflecting something else. So as you move, the reflection is going to change. So it's basically getting the algorithm confused because you see a point in one picture, then you see the point in the other picture. He thinks that is in the same position, but he has been shifted. And that's why if you try to do 3D model or using photogrammetry of a mug that has a lot of reflection, you will end up with the two handles because it gets easily confused. If you try to do 3D scanning of an object that doesn't have features, like completely white element or a completely white room, it's gonna get confused because it doesn't have reference points. Transparent object, still a nightmare because you don't find steady features inside. And of course, structure from motion works for objects that they are steady. So if you try to do things 3D model of a person that is not steady, it's gonna get all changed. And in fact, you get really creepy results if you do 3D scanning of a person, unless they are sleeping or doing yoga. I tried with my wife when she was doing no yoga, meditation. When she was doing meditation, I did a 3D model of her. So lighting condition can dramatically affect the results. That's why when you have shining object, it's always good to have weather like this, that is spread the light with diffuse condition, so you don't have shadows that they move around. Imagine that you're doing a 3D model of a building and it's a sunny day. By the time you finish one side, you go to the other side, the sun, of course, is moving, or the earth is moving, depending who you ask. And you will see that the shadow that is probably one of the reference points in the image is keeping moving. And if you're doing it over half an hour, you're gonna get a mess because all the shadow have been swapping around. There are solutions to trick the problem, and it's by using really intense flash. Those flash are so intense that if I shoot on your eyes, you're gonna get blind for a couple of minutes. and they overcast the sun. So if we use them outside, you will see that they are stronger than the sun. And in this case, what you do is to polarize the flash. So you tell the lights to wave only in one direction. You take the picture, and then you control-polarize with a filter on the camera. So eventually you capture only the light that has been shot by the filter. And by doing that, you remove all the reflection. And if you start taking picture, and I put also a YouTube video showing some example done with this setup. If you take a picture of silver, you will see that you remove all the reflection of the silver, and the silver doesn't look any longer really appealing. Even gold, if you take a picture with this setup of gold, you'll see that the real color of gold is a really yucky yellow color. It looks like beautiful to humans just because it has all the reflection capabilities that make it look like shiny and beautiful to have. So you can use this setup, and it can be quite expensive because you need a decent DSLR camera, then the filter. You might end up easily to spend 5,000 New Zealand dollars for one of these setup. It depends if you really need it. And this video really shows some good example of what will be the benefits of using it, using a leather shoes that is really reflective. The other possibility is to spray shiny objects. Of course, good luck going to the David of Michelangelo and spray it. The reality is that there are sprays that you can use with even piece of art because they evaporate. So you spray the object, and then by the time you finish, it evaporates, and so it releases all the chemical that you apply on top of the surface. So really good for mirrors and small surface. If you need to do the IC building, good luck. Spray all the IC building, so you can scale it up so big. And there are other people that went a bit nuts using photogrammetry to recreate a 3D model of actors. And this is an example with the setup that I showed you. Multiply many times. So in one shot, you manage to get picture from all the direction of a person. So it's doable, pretty expensive, but people have been using it quite for a while. And they use it a lot in the cinema industry. When you want to do CGI, you want to recapture the 3D feature of an actor and then model it. So back in the day, I was suggesting two apps. Scanamaze is dead. It was free and it was fun to use. I've been using it quite a lot. The only one that I will suggest now is to start using Polycam, and I discovered that many people in the industry use Polycam as well. So it seems that it's getting, it's really popular. So it's not bad at all. An example that I did with Sketchfab, but Scanamaze, but you can do it with Polycam. It was our chicken wing. So in that case, I went there with a leather scale because I'm not tall enough. DNA issues. So I was going up and down, so to be able to take picture also from the top. And intentionally it was a day like today. Cloudy and pretty awful. And this is the results. The good things with the Scanamaze is that you can import directly the model in Sketchfab. Have you ever used Sketchfab? Sketchfab is a good tool where you can put your own 3D model. Let me go and get directly the link from the presentation. So you can put the 3D model that you just scanned, the mesh that you've been just reconstructing online, and send it to your clients, or even make it downloadable for the rest of the world. So this is our chicken wing. So whenever you leave Messi, if you feel Messi sick, like you miss Messi, you can go there and download it. So you can see that is accessible to everyone. And if you use this application on your smartphone, then you will have the possibility to have the VR visualization mode, and then you need just to use a cheap box, plastic box. I can show you one of them later. And you have VR for $20. You can buy those boxes in Kmart. They don't cost much. And using your smartphone to do the 3D model, do VR, you can see that you have a VR setup at home for nearly $0 New Zealand dollar. So let's go and see the other example, for instance. You know this guy? This was during the open day last year. They brought Fergus. I told the guys, stand there for minutes, and so I managed to take a video of it. And you can see on the right-hand side the resolution of the 3D model. You can see that there are some problems here. I didn't do a great job, but you can fix this kind of, you can cut those meshes and fix them whenever you don't get really good results.
Beautiful.
So you can do a lot of crazy stuff. And then if you don't have anything to do in Easter time, you can even decompose these 3 models and create offshore manufacture. How do you call it? Prefabrication. You decompose it in something that you can buy online, and after a couple of weeks, you can get it back home, something that is workable. And is it difficult to do it? Software that I managed to find online is called Scene. It's called a Studio, and it's free software you can download and use it to decompose any 3D model in a Lego. So in that case, if you want to quickly see,
That's for basic models, right?
yeah,
Okay.
if you want to have a basic model of this chicken wing, we can download it. Let's try to download this one. 6 megabyte. Let's put it on my desktop. And now I'm gonna open the software and show you. No Scene Studio. So I'm not gonna do the upload today. So if we go here, can create a new model. We go to import a 3D model. The chicken wing was already there. And you can see here that he has already reconstruct. Then I can even decide which size it should be, because if I want to spend a lot of money, I can say, okay, the base should be 100. And then you can tell, so you can see that this piece now is gonna be thousands. That means like you're gonna pay a lot. Let's keep it with all the possible color. And there you are. The 3D reconstruction of our chicken wing. So if you really feel that you miss Messi, you can spend a few thousand New Zealand dollars to build your chicken wing at home now. But joking apart, this is what happened when we do prefabrication. There are some blocks and you try to use specific elements to rebuild something that is customized. And of course, it depends on the technology that you're using, and it depends on what is the product that you're gonna use. So there is a lot of things that can be done to automate. And if you wanna see one of the chicken wing, we got them And generally, it's the things that I do now when I go and travel overseas. I bring this as a present to my colleague. Because you can even build instruction. So I give them the manual and then now I tell them, this is my gift now. Waste your time. Try to figure it out how to build it. So you can see it's just Lego. You can export all the pieces in CSV format, import it in Lego, order them, and just wait for the courier to bring it to your place.
You didn't make it?
Hmm?
You didn't make it?
What do you mean?
No, plastic is expensive.
Yeah. And then if you hate the environment, you can bring the Lego and throw them in the sea, right? Nah, don't do it. Don't do that.
It actually is Lego.
It's a real Lego. So you can see here that you have also the possibility to import 3D models in PowerPoint. And with the same model, if you copy and paste in different slides, and then you put a morph transition, then you can do all this kind of crazy visualization. And why not? You can create an avatar of yourself. Is it free? Of course. You can try this application. It takes 3 pictures of your face and then it creates the 3D model of yourself. And you can even cheat on it because you see, you can remove the belly.
Can you use regular selfies to make a realistic, recognizable 3D avatar? Do it inside your own product with Avaturn, a new realistic avatar platform where any user can become a 3D avatar under a minute. Avaturn easily integrates in your product through web. It works great with Unreal Engine, Unity, and most web solutions.
So it's basically another way if you want to make yourself a bit different from the rest of. The new technology that is out there is called Gaussian splatting, and this is a blended combination of old way of doing stuff with structure from motion and new way to do stuff using a bit of machine learning. So we are gonna quickly show you why Gaussian splatting is good. So the latest technology is called Gaussian splatting. And if you want to understand a bit of history where we reach, how we managed to get to Gaussian splatting, there is a video here that I select from one of the inventor of Gaussian splatting. So this is what the algorithm look like, guys. So you start from structure from motion on the left-hand side. So basically, at the beginning, you have the points that you will reconstruct using traditional structure from motion. And we have already watched a video how this part works. This is how a Gaussian look like, a Gaussian bell looks like in 2 dimensions. It's just a bell curve. If you have it in a 3D space, in 3-dimensional, you have basically something that looks like a rugby ball. And this is the principle that you have multiple parameters to define these rugby balls. And by changing the parameter, in this case, in the 2D spaces, median, average, and standard deviation, you change the shape. You can do exactly the same in changing the shape of these rugby balls. This is how it looks like in terms of equation. Looks like rocket science, but it's just simple calculus. And you will see that for each point, you have a different values of, you can put inside the scale of the dimension of the rugby balls. You can put the colors, transparency, and stuff like that. So this gets done to start the first iteration of Gaussian splatting. So for each point, you put there a Gaussian splat. And you see that initially it looks like a mess. But then you go within the iteration process in which you use the machine learning process, in which you try to figure it out if you need to clone the object, the Gaussian, create more, and how to adjust them so it can match the shape that you try to achieve. And you can reach this using different pathways, starting from something that is too small, or if you start with something that is too big, you can split it in two and then optimize to recreate the shape that you're trying to do it. So this is done in 2D, and this is how the visualization gets done. All these bulb then get rasterized, and this is how it looks like in a final image. It's what happened also in video games. You rasterize, that means that you try to figure it out which element in the 3D points are before the others. You shoot basically laser beams and you try to figure it out which one is the first element that you shoot. So that's gonna be in the front. And then you build the scene. Once you build the scene, then you can go back and compare with the original image that you had. And so you can iterate the process many times until you get the best results in terms of 3D model that from the specific point where you took the picture looks like the pictures. And this is an example how this process works from really big splatter to a 3D model that looks like almost photorealistic. The good news is that this technology is already in Polycam, so you can start using them straight away. There are different pros and cons, and I'm gonna show you quickly some example that shows what you can get out of it. Because sometimes you get really good stuff for photogrammetry when the objects are really not shining, all the limitations we were mentioning before. So if you try to do a photogrammetry, this is a photogrammetry and Gaussian splatting of the same object, it might look like exactly the same. You don't see the difference in this. But soon I'm gonna show you some example in which with the same amount of data, you get results that are far better. So this is the case study that I'm gonna show you. This is a video footage of a drone. This is a building based in San Diego. It's a building that has been used for a lot. It's used for a lot of research because it's built on a shaking table. So they shake the full building to simulate earthquake. They turn off fire on this building to understand how fire can propagate on a facade. So it's a building that is used for research for many different purposes, funded by National Science Foundation of US. So they invest, I don't know, hundreds of millions of dollars to create this setup. And you can see that is a drone footage because you see the car behind moving on the streets. So now let's go and see the results. Gaussian splatting and photogrammetry. You can see here all the details of all the elements completely gone in photogrammetry. In Gaussian splatting, they are still there. And of course, I did that in Polycam. So I want to show you the results. Let me find out where it is.
There was something there.
No, it's one of the latest. Ah, there you are. So this is the photogrammetry, but I want to show you you see the splatting, they get reshaped. You see the resolution that you get. And of course, if we move away from the scene, and now you can start seeing all the rugby balls that we were talking about. Because we don't have data to train and understand what is there. So you can see all around is a mess because we didn't have data. But as we get closer to the object, then you start seeing that the results is pretty impressive. And if we go and open the equivalent using photogrammetry, you can see that is a mess.
Quality is not good.
So it's a good solution that is getting with the same amount of data, much better resolution. And this is an example of another software that I found that is online and for free, in which I upload the same video, and this is how it looks like after the reconstruction. Even better than the one before. It's not a video it's just a 3D model. In fact, you don't see any car moving because sometimes I need to tell people I'm not cheating here. And we tested also this other software that is for free to install on your PC, but it runs locally, so it might get your computer destroyed because it can run for weeks or hours. It depends on the setup. And this is the 3D reconstruction that I got from this video. So far, far better than photogrammetry. I managed to find some video that were trying to compare different software. In this case, I didn't try CuriEngine and Teleport. CuriEngine is because they want money and didn't want to pay for the license, but it seems that it's a relatively good engine. And I like this video because he managed to use exactly the same data with a really complicated object, something that is shining, and he has a metal. It's glasses, all glasses, and he has a metal structure in it. And you can see that some algorithms are not capable to capture the details of the metal inside. And post-shot, that it was the last software that I showed you, he managed to even get the information of the metal structure inside. And if you don't trust me, scan this QR code and walk around. Do it. Get your phone and scan this QR code. So this is another way that you can use to show the project to your colleague. You can put the 3D model in a scene like this one and ask them to walk around. So you will see that you're gonna be teleported. I'm gonna do the same here. I'm gonna copy the link. And we are gonna meet all of us online. See that now we are online, all of us, and we can go and have a walk around and see the 3D models. So the one that I was telling you that you can see the metal structure inside, it was this one. And I can see a lot of you. So this is another example of how you can use non-immersive VR to bring all together in a single project that is on the other side of the world. So you have a 3D model, you can tell them, this is how it looks like. Have a walk. Any feedback? And developing software like this is not any longer a challenge. It's just a matter to find the right tools. You got lost?
The control got stuck.
Probably you need to buy a better phone.
He answered one.
Yeah. You're a woman.
Why am I female?
Because it's politically correct. And we, yeah. I'm not making difficult question about what is a woman. Seems that it's becoming too controversial to answer the question. So let's go ahead and see another video. This is another solution that has been proposed just this year or later last year, and it's using guys. This is another solution that has been proposed using, instead of Gaussian splatting, triangular splatting. So instead of using the shape, they use triangle because general triangle is what we use in rendering. You mind telling them that? Seems like triangular, the one that meshes. So our graphic card and rendering pipelines are much more optimized to handle triangles than rugby balls. And this is an example that I found from this guy that this video. So the cool things about this video that it looks like a video, but soon you will realize that it's not a video. It's the 3D model using the triangular splatting. And in that video, they managed to do some comparison, showing, if you zoom in somewhere here, you lose the reflection. If you use Gaussian splatting with triangular splatting, you can see all the details. It depends on what you want. I bet that when you were at the beginning of this video, you wouldn't have been capable to tell this wasn't a video, but it was a 3D model. But it's a 3D model. And if you try to do, this is the difference between Gaussian and triangular splatting. If you're asking yourself, I don't see much different, that means that probably they are equivalent. What if we want to use only 2 images? This is an example found last year in which you just use 2 pictures. In this case, I used 2 pictures of a rubbish bin that we had here in the lab. Take a this picture, and this is live conversion in a 3D model. So you'll see that it's going to take a 20 seconds roughly. Let's speed it up. Otherwise we fall asleep, and this is the results. 2 images. It's not perfect, but you can get where we are getting to. The question that you should raise in your head, what if we use only 1 picture? So one of these is a picture from an IKEA chair. Since we are opening finally IKEA in New Zealand, we succeeded with the most challenging things in the world, so opening a store. One is a picture, one is a 3D model using Polycam. Because now you can basically use generative AI. If you train a model to know all the furniture, you can put them in Polycam. The single picture, then you rebuild the 3D model. And then if you really start looking the detail, you will see that there are some parts that don't make any sense. So now you need a 3D model of this chair. I take a picture of it, I put it on Polycam, and within a few seconds, you get the results. So there are other solutions that have been put in together, and you can see that robotic is using a lot of this Gaussian splatting to train themselves about how to use the perception of a space and move stuff around. So there are a lot of projects that are making advantage of this new way to do 3D modeling in such a quick way. And there are other software that are available if you have an Apple device. Especially with the Apple device that they have a ladder on top, you will see that the most expensive iPhone, they have another dots behind that have the ladder. That is basically using infrared. So infrared is pretty much working as a laser scanner. The infrared has issues though with all black surface. Why? Because black surface absorb infrared. That's why they get hotter in summer. So whenever you have infrared, you will see that if the sensor is not really powerful, nothing's gonna bounce back. So you'll get issues. But you will see that the Apple has managed to create a relatively good application that allow you to quickly create a 3D model of an environment. It has been customized for rooms. So using that kind of solution, you can quickly create a 3D model of a room. And there are many other solutions that have been proposed for Android or Apple device. And those are just some examples done by Rio. This is even a 3D reconstruction of the Lighting Lab, quickly done with a tablet. It's not high resolution, but you can get the sense that we are getting really good at creating 3D models. Then, of course, you can use it in mixed reality. And if you ask me what's the difference about augmented virtual reality will give you the possibility to blend the 3D models with the reality. And virtual reality is basically just all digital. That's what you get when you have a video game. So that's an example of non-immersive virtual reality. From a scientific point of view, you see that it's nothing new. All these definitions were already there at the beginning of the 90s. So whenever you see people coming across and say, we have a new generation of metaverse, it's just bullshit rebranding stuff that is already there. Or spatial computing, another bullshit to rebrand something that we knew already for the last 40 years. Nothing new. So sometimes you need to be careful with the people that rebrand technology. Most of the time, after the first virtual reality headset were released, they start calling them mixed reality. You try, and it was just virtual reality. And I was asking colleagues, can you tell me the difference? It's like, if it takes too much words, it means that we are talking about the same technology. It's just because there were already two competitors in virtual reality that were doing the best product, that everyone else was trying to catching up and inventing a new name and misuse an existing name, mixed reality, to rebrand existing stuff. And we do it in science. You will see a lot of my colleagues start using fancy terms just to talk about VR and augmented reality. Don't get fooled by people that try to use advanced words to make you confused and make them look smart. Whenever you find people like that, walk away. So virtual reality, back in the day, no one knew, but in reality, everyone has been used virtual reality with video games. What we associate now with virtual reality words is the possibility to use virtual reality headset. This is my favorite. It's a Quest 3, and it's a good combination between price and what you can get, because you get also the possibility to have augmented reality with this, because there are cameras that stream real-time what you look inside, and you can see holograms in the real space, or you can have a completely VR headset. Guess how much they cost? $800. So you can buy it for Christmas, right? Instead of buying a car. And if you want to do something fancy, have you gone to the leaflets? If you want to have a premium experience about virtual reality, you can use one of the most advanced toys that we got here. The headset just arrived a few weeks ago with Sweden with the students. You can have and try the driving simulator in virtual reality. We just started yesterday with this new experiment, and it's something unique that probably will go to an arcade and pay for it. You get it for free here, and you even get vouchers. What do you want more from life? That's the simulator that we are using. So if you want to have a try, scan, get your spot, come and have a try. It's pretty fun.
I'm gonna definitely do it. I needed $20.
Yeah. There you go.
So
Butter.
I'm gonna make a video to make butter with cream. You can save $2. And don't use butter. It's not good for the health. Use olive oils. My father sells olive oils. So a bit of conflict of interest. It's healthier. So augmented reality, how many of you have used augmented reality? We all been using it, especially if you have a reversing camera. Unless you're in Italy, you don't use it, you use physics. When you bump into the other, you know that's it. You can't go any further. Or Pokemon Go was one of the best games that was advertising quite a lot augmented reality, but it can be used for quite a lot of interesting things, even to overlap 3D model of a project on a real project. And all this stuff, VR and AR, can be quickly used if you don't want to use advanced stuff. This is an example by using the headset that I was telling you and Sketchfab. Or this is an example of an augmented reality. Use PlaceMe. Is a software that it's a web page where you can upload any 3D model. This was my avatar. And this is the augmented reality in my lounge. You can see the avatar of me in a real space. I need to skip back to the other presentation because I was working on the wrong one. And there is a lot of AI stuff happening. And this is one of the latest software that I discovered online. And it's pretty cool.
This is Reno, and today we are gonna just have a quick test about the use of AI to improve our workflow for the construction industry. Just find this application that seems to be capable to beamify something starting from a 3D plan.
Let's just watch it.
What I actually done is to download an example of PDF, and I'm gonna upload it and try to have a look if it's actually delivering what is promising. So you can see the floor plan PDF is up here. So it's asking me.
So it's capable already to detect the scale.
The condition. Let's have a look. What is capable? Wow. Wow.
So this done in few seconds.
That's pretty cool. And
You have
it's
straight away a 3D model, and it's actually not a 3D model, it's a IFC file. So it's basically BIM.
And I'm gonna actually save it on my desktop. And what I'm gonna do is to open one of my free IFC viewer. So let's try to use this one of my favorite to check, especially if a file is readable. And I'm gonna go here and open the model that we just created. And wow, yeah, most of the time you will see that they are corrupted. It seems that it's done a pretty good job.
It's done like this.
So, and then you can of course implement and use them with any other software that you need to have. This other video shows here, I import one of those 3D model created from a floor plan and use a CFD software to put a heat pump. And then you can do CFD simulation showing the impact of a heat pump in a space. So I have also other example. Henny sent me one IFC file of his own project that he's doing from research. Put in PyroSim, that is a software we use a lot for fire simulation. And you can see it. That this is the 3D. The software, the office, you can see here that I put a couple of vents, one that is spit air inside the domain, hot air, and the other one, the blue one, that you get the air inside. And by adding this, so this was converted from IFC file in the CFD file, and by using this configuration and running a simulation, then you can get something like this. Let's hide the ceiling. This is the graph of the temperature that shows how the heater is going to work in the environment. So you can make even an estimation if you install different solution, how long it will take to heat up a space. It comes with limitation on the grids that you're going to use. So CFD is not that easy to understand in the few details. So you need always to understand what is the assumption that you're making, and if the assumption that you're making to discretize the space is aligned with what you're looking for. And there is a lot of stuff happening in this space. In fact, yesterday I was showing, because I made another tutorial. Have you ever used Blender? Blender is a 3D model software that now has the capability to create a CFD simulation. And this is just the example of me yesterday being an idiot and create a simulation of a marshmallow be burned on top of a fire. It's basically the possibility, you have the possibility now even to import EFC files, BIM file within Blender, or even use Blender in equivalent way of Revit. There is a new plugin that is for free called Bonsai that allows you to sketch model of a house just using Blender, like you will do it for with Revit, but with zero cost. You don't need any license. Blender is free, Bonsai is free, and you can go and have a look at, just to get a sense of what you can get. I just made a video last weekend. On the work floor, or you can go from a PDF to Blender and then convert that information in a CFD usable file. So it will allow you then to run simulation of a fire, in my case, because I do a lot of fire protection engineering, or you can do a simulation of heater or any other stuff that might require CFD. So it's just a matter to connect the dots, and most of the time the software are already there. It took me just a couple of days to figure it out what was the best way to go from a PDF or an existing BIM to a CFD simulation. And guess who I asked for help? ChatGPT. Ask, can you give me some hints about what platform I can use? And it will say, you might try to combine these two. Then I start reading the documentation. I said, seems like reasonable. And after a couple of days, I was able to do all the conversion. And $0. Just a bit of time and creativity. So, and that's it for this presentation. If you have any question, if you want to have any live tutorial about something that we have been watching, you can do it together. Or if you want to have a go with any photogrammetry software, we can do it now. Hope you enjoyed this session. It's pretty intense of information, but it gives you the idea that at this stage there are a lot of stuff that is already on the internet that you can download for free and you probably don't even know. Just use YouTube most of the time to discover what is the latest technology, and ChatGPT to figure it out where to download stuff, and you can develop a lot of cool stuff. No worries.
Very impressive.